Okay, so we're continuing our discussion on quadratic functions, and we saw that the simplest form and the easiest form to work with is to have it as a times x minus p, everything squared, plus a q. Then we can see the transformations very clearly. The a might have a positive and a negative component, giving me two transformations, but still, it's pretty obvious when it's there. The x minus p corresponds to a horizontal shift of the graph, and the plus q, which could be negative, corresponds to a vertical shift of the graph. So having it in that form is quite straightforward to use my transformations from the basic function. Just notice that if I were to transform this systematically, in the end, it does depend exactly on what the numbers look like. But let's pretend these are all positive numbers. My parabola is going to maybe be stretched a little bit. It's going to shift from that center point to the right by p and maybe up by q. So I might have a parabola that sits over there. The new coordinates of this bottom vertex point will necessarily be p and q. So the vertex location is immediately clear from this, I'll call it the PQ form. Don't really know. There's no agreed upon name for this form. It's a simple transformation form. So if I can get it to this, then I pretty much know everything about the function, about the parabola, about the shape and the location and everything. But there's also the standard or general form, which is the simplified version of this. After I FOIL everything out, I'm going to get an x squared term with an a in front of it necessarily, some other number b in front of the x, and some other number c, after I've simplified it. And here, there's not much that is immediately obvious in terms of properties of my function. So I want to make it look like the top version to be able to use transformations and everything. So we want to make it look like this PQ form. And we're going to do that by completing the square. So let's look at our problem book. I think we're in 1.6. Let's go with number 3. This refers to the problem book. Let me see what exactly it is. Let's copy it down here. Yeah, they say f of x, but I'll say y because we're looking to graph it. Y equal to x squared minus 2x minus 8. So I'm not making it the most complicated with a different coefficient for the x squared. Just keep the x squared on its own. So we can try and remember this completing the square method, which not everyone remembers very well. So it's good to just have a slightly simpler example. So my goal is to make it look like that top one over there. So if I think about this a little bit, then looking at the x squared minus 2x, there's a third piece to these two that would enable me to write them as sum bracket squared. And 8 is not the right number. It's not the one that fits with this. If I'm now looking for an x minus p to square and simplify backwards, giving me the x squared and the minus 2x, the x is definitely correct. Because when I FOIL this out, how do I do that? Maybe let's go over here. It's going to be x squared, the product of the two times 2, and the last one squared. So the x squared is definitely what I will get, so that's good. And that comes from this x. I have to choose a number for p so that I get this required minus 2x. I don't have a choice, it's minus 2x. It's given in the question. So what should the value of p be to get me this minus 2x? It's a number, it's not silence. Well, if I look at this, this should be, or must be, negative 2x. So what should p be? P has to be 1. Because when I simplify this out, it's going to be a minus 2, and then times a p. And I already have a minus 2. I don't want to have that different number. So p has to be 1. So that then tells me that this has to be 1 squared. Because the only way to get the minus 2x is to have p equal to 1, which means this third part of this bigger bracket has to be 1 squared. So let me erase the question mark and put in a 1 squared. But that's not what I have. I have an 8. So in order for me to bring in a 1 squared, which I know is just 1, I'm going to take it away as well, and then just let that minus 8 hang around. It's not the one I wanted. It's not the number I wanted. I want 1 squared. To bring it in, I have to take it away again, so everything is balanced. Again, it's not the only way. If you do remember how to do this, that's my way. I need to get these 3 correct. And if the 8 doesn't work for me, I'll bring in the number that does work for me. So now I still have these numbers to account for so that everything is equal. And when I clean it up a little bit, I have x minus 1, everything squared. That's a 1 and an 8, so minus 9. This 1 is just a little low for my liking. Let me get rid of it. Put it over there. And there we go. So it's a little bit of a story, I like to think of it, that you're sort of talking through, sometimes going a little bit ahead and then working back what you needed to have to get what you want. How does that feel? Probably not great. That's okay. It's not just you if you think it is. Yes?
Can you go over the other ways here?
I don't want to, no. I can do it in private. But it's essentially the same. There's no real difference. I think this one is a little bit easier if you go from nothing to understand, if you have to choose one. But they are essentially the same. Giving too many options is sometimes not helpful to everyone. But I can totally do that for you afterwards, yeah. There's no benefit to it just confuse people. So let's take one where we have a more interesting x squared. We probably need to practice this a little bit more. I think I can fit it in. So let's stick to 1.6 and do number, I don't know, maybe a 5 is a little bit similar. Let's see how bad it can get. Let's do 6 or 8. Pick a number, 6 or 8? 6. All right. Now I have y equal to negative 3x squared plus 4x minus 7. And remember, I'm not giving you anything to waste your time. There's a lot of pre-calculus stuff off the record that you don't really need that much. I'm only doing things that we will use a lot, or I will put in a midterm. I won't waste your time with things you'll never see again. So, the first step now, if there is a more interesting coefficient in front of the x squared, is to take it out. It's not what I'm interested in right now. But in order to do that, I'm taking out -3 from every term. And I'm probably going to create some fractions. It's now going to have to be a -4/3x. But what I could do to make my life simpler is to not worry about the -7. Chances are it's not going to be the number I'm looking for. I'm not even going to bother. Even if it is perfectly the number I'm looking for, there's no harm in just leaving it out of this discussion. And it needs to still be there. I'll drag it along, but it doesn't need to factor in that much and confuse me further. Let's leave it out. I don't want to look at you -7, but you still need to be there. Now, the -3 I'll just keep in front there. I'm looking for the third part to this trio. And I'm stuck with these first two. The first part, the third one, sorry. The third part I have to sort of choose. And I'm going to take it away again so that everything is exactly the same as before. I have to figure out what is that third one so that these three give me some bracket squared. I'll call it P for now. It's going to be a minus because it's -4/3x. The question is, what is the P? So now I sort of work a little backwards to figure out, well, if I FOIL this out over here, I know that x minus p squared is going to be x squared minus 2px plus p squared. I'm stuck. I know what the x term is. It's -4/3x. So that means that the -2p in front of the x has to be -4/3 because that's what's actually in front of the x. And therefore p has to be anyone unsure what I'm doing? Where did I lose you? First line? No, that's just the question. Second line? We just have to remember the coefficient of x squared, just take it out. Don't want to look at it. I need it there, but I don't want to play with it. And the last constant term, I don't want to play with that either. So I leave the last -7 out of everything, and then take -3 out of the first two. That's always what I'm going to do. We didn't need to do that in the previous example because it was just an x squared. So that step was saved for us. And we essentially just had that bracket. So now I'm left with that third line. So I'm making a plan first. My plan is to find the correct third part of x squared, the x term, and something else that would make a bracket squared. Three things make a bracket squared. No? Yes? Maybe? Because if I'm looking for an x minus p squared, right? That's what I'm looking for. It's the form I'm looking for. If I were to have that, simplifying it backwards has to give me the very top in some way. So if I just ignore the -3 and the 7 for now, pretending I have this bracket squared, then simplifying it has to give me these three terms. So I'm stuck with an x squared. I have to have an x squared when I simplify this. And I'm also stuck with this -4/3x because it comes from the question. And that middle term tells me that this p can't just be anything. Because if I just choose anything here, if I just choose a 5 and FOIL it out, I won't get negative 3 over 4. 4 over 3, sorry. I won't get it. So this P has to be a specific number that when I FOIL it out, it gives me the target the question requires. So I don't really have a choice. These are connected. Not any old P is going to give me this minus 4 over 3. Now, if I were to just leave it as a P and FOIL it out, that is how P affects that X term. There's always a 2 coming out, but the P is always there as well. Now, I know the answer has to be negative 4 over 3. So what should P be so that when I FOIL it out, I get exactly 4 over 3 then?
Negative 4 over 3 divided by 2.
Divided by 2, so 2/3. 2/3. You can always test it. So now that means that if I can erase this P, there's only one number that's going to give me my X term exactly the way it should be. And it's 2 over 3. Because when I FOIL that out, I'm stuck with the 4 over 3x. The question requires it. And the number that's inside the bracket that would give me that after I FOIL it out backwards is 2/3. Once I have that, that then tells me that this question mark third part can't just be anything. Because if I FOIL this out backwards, it's the last one squared, the second number squared. They're linked as well. So, oops, erase. So this question mark has to be 2/3 squared. Because that's what I would get when I FOIL it out. It can't just be randomly anything. They're all connected. And so this was the number that I needed to bring in to complete this trio, which means I have to take that away as well so I don't change anything. So what I have now is negative 3. I'm going to use big brackets. The bracket squared minus 4 over 9. That still needs to be multiplied by negative 3, and the minus 7 is just hanging out, waiting to see what is happening. Completing the square, there's a reason you don't remember it. You did it. I guarantee you did it. Everyone has to do it. But no one remembers it because it was so traumatic. You blocked it out. I guarantee you did many of them. Now it's a matter of just making it look pretty. And I'm going to multiply the negative 3 back in to the bracket square and to the minus 4 over 9, giving me plus 4 over 3. And then the minus 7 is still there. Oh, I can squeeze it in. I just have to put the constant terms together. 4 over 3 minus 7. 7 is 21 over 3. 4 minus 21, negative 17 over 3. Wasn't that fun? No, that was not fun. Actually, I enjoyed it. Like anything, once you've practiced it enough, it does get easier. We don't have a lot of problems because it is technically reviewed in the problem book. So feel free to go look at your old pre-calculus books or whatever if you need more practice than what we have. Any questions you can ask now? Yes?
Can you go over like the bottom right, second line, how you got...
Second line. That is not to make you feel good or bad, but that is what everyone needs to know from grade 9. How you simplify a bracket square.
Yeah, I know, but
That's the second line, right?
The step after that.
Oh, sorry, you said second line.
Second to third line.
Third line. Oh, okay, okay. So my question, very top line, the function is given. When I take out the -3, essentially that 4/3x is given. I'm stuck with it. Right? So whatever number p I choose in my bracket squared is going to have to, when I simplify, give me 4/3x. And because when I simplify it, I get 2p, that means the 2p has to be 4/3. This is given. I have to get this. But I can choose the p in order to get that. So these two have to be the same. The 2p and the 4/3, they have to be the same. 4/3 I'm stuck with. I have to get that. My question is simply, what should p be to give me that 4/3? And because of the 2, p, I divide by 2 to get 2/3. And then you can totally test, right? If I try this, let's say on the side here, where's my cursor? X minus 2/3, everything squared. First one squared. Product of the 2 times 2 is 4/3. Plus 4/9. So I get the x term that I'm supposed to get. I'm stuck with it. I have to get that. The question is just, what should the bracket squared look like in order to get that? Lots of things happen. Nice. Good, good. So then I could look at this. Let me zoom in. I could look at this guy and say, okay, I can make my chain of transformations. You're welcome to do that on your own. It's what transformations, how many, let me ask that, how many transformations do I see in there from the list that we made? How many transformations do you see? Do you see any transformations? That should really have been a yes. That was a question, right? I asked a question. That means you answer. Do you see any transformations? Am I speaking English? How many transformations do you see?
5.
5? What are they? In no particular order. It doesn't matter, right? We're not actually graphing it.
So,
Or left to right. What's the negative doing?
7. Is it reflection?
Reflection. What's the 3 doing? If it helps, this will be a midterm question.
The vertical stretch compression.
Vertical stretch, because it's 3 in this case, it's stretching. What is the x minus 2/3 doing? Horizontal shift by an unpleasant little fraction, which is why we're not graphing it. What is the minus 17/3 doing? It's vertical shift. Lots of transformations happening there. You have to see them. Now, a midterm question could just ask you to chain the transformations one by one. Then you just want to remember that this vertical shift should really be the last one. Other than that, I don't care. Or it could ask you to graph the whole thing, but then I won't make unpleasant fractions like that. We can at least give you that much. Where's my cursor now? Can I have a cursor? No? You don't want me to have a cursor? Apparently it says, no cursor for you. Okay, let's have a new page. So that was completing the square, getting it to the form where I can just see exactly what the features are on the graph. So we have the form y equals a times x minus p squared plus q, great, versus y equals ax squared plus bx plus c, which you'll more commonly see, the simplified versions. Now, so it's okay, you can get on top of completing the square with specific numbers, with a specific example. That's going to be okay. With a little practice, you can do it. If we were to take the general right-hand side of those two, the right version, without having specific A's, B's, and C's, and you leave them general and you complete the square with that, it takes a little longer because nothing simplifies, but if I take this and I complete the square in general, I'm going to get that y equals ax plus b over 2a squared plus some other stuff I don't care to memorize. That's what's going to come out. And that tells me, I'll show you I'll show you in a second why I don't want to write the second bit. That tells me that p is equal to negative b over 2a. So there is a formula that helps me to avoid completing the square every time by doing it once in general, that this p, which remember is the location of the vertex, right? Let me graph it over here. Let's put it in a nice simple position, assuming that everything's nice and positive. We did that previously. Let's put it over there, parabola. Ooh, my parabolas are good today. It's a good parabola day. Is negative b over 2a, the x coordinate of the vertex. So there is a way to sidestep completing the square. And this line that obviously splits the parabola into two mirror images of each other, we'll call that the axis of symmetry. So the axis of symmetry is really just the x location of the vertex, which, if I'm looking at the general simplified form, it does come from a combination of the coefficients, negative b over 2a. So I need to memorize negative b over 2a, negative b over 2a, negative b over 2a. That's not that hard to remember. Maybe you do remember it already. How do I find the y coordinate of the vertex? Yes, it's the q. Yes, it's this. Do I care? No, I don't care. If I want to find a y value of the function, if I have an x value, I simply plug in the x value and calculate it and find a y value. I don't need a new formula for that because I will, in my questions, have a specific example. There's no need to memorize b squared minus 4ac over whatever nonsense. I don't care. There's no need for it. Minimize what you memorize. Understanding is always better. As long as you remember this guy. Does negative b over 2a look familiar? No? Nothing's familiar? It's okay. If this is all brand new, then your course just starts a little earlier. Because as we progress past this point, there's always going to be some new things. So it's all good. It doesn't really matter. That's why I'm doing it. So if we now have an problem, 1.6, number, let's maybe take number 5, maybe. We have f of x, or y, equal 2x squared minus 4x minus 1. Now, as much fun as completing the square was, I know it was a good time, and you want to do that every time, it's not the best time saver. If you want to save some time, a formula allows you to do that. So here's what we're going to do. We're going to list a couple of things. The key things I need to know is this coefficient a. In this case, is it 2. Now remember, the a is the same a as my transformation up here. So if that's a positive 2, what are the transformations that are happening to the parabola? If it's a 2, positive. It's just going to stretch it. It's not going to flip it. So just looking at this a, it's the same a, that implies that my parabola shape stays up and everything, yeah, it's going to be stretched a little bit, but nothing is flipped around. So the A does tell me something. Let me just actually clarify that a little bit more. It's positive, and that means parabola pointing up. Second thing, I want to locate the axis of symmetry. Past the general shape, there's really only the vertex. And lastly, the Y-intercept. That's important here. So, axis of symmetry is when x is equal to negative b over 2a. And in this case, we have negative. B itself is negative 4, because in the standard form it's always pluses, right? So B is negative 4. 2 times A is 2. And I get a very nice little 1 as our example. But sometimes it could be a fraction. It could be something a little less pleasant. But it's always nice when it's a nice integer to work with. So that's how I use that, and it's a very simple formula. I am not going to require you to memorize any fancy new formulas. Then the third one is, now I know that this vertex sits at the bottom here. The x location is 1. And because this is the bottom of the parabola, we'll call that a minimum point. So the minimum function or y value is happening at this x, right? We said we just plug it in to get the y value. So I'm going to plug it in and use my calculator, do it in my head, do whatever I want to do to get the y value. There's no need to remember another formula. I've used it so rarely to the point where I honestly don't remember the formula, because there's no need to. I remember things that have a need. It's negative b over 2a. I don't need. If I plug in a 1, 1 is nice and simple, so I get 2 minus 4 is negative 2, minus 1 is negative 3. But if you need to use a calculator, that's fine. So lastly here, we will find a Y-intercept. That's always easy to do and important. How do I find the Y-intercept? Set x equal to 0. That means I'm really calculating f of 0. Now notice here, there's nothing to do, because that guy's going to fall away, that term is going to fall away, it's always going to be this guy. So the standard form isn't completely useless. This c is always going to be the y-intercept, because it's when x equals 0. Doesn't tell me a lot about the vertex easily, but it does have that intercept look to it. So it is a negative 1. And now with this information, I'll zoom out. With this information, I can very easily capture the essence of the graph. It's not going to be perfect necessarily, but it's going to be good enough. Locate my axis of symmetry. Let's put it over there at 1. It has a y value of negative 3, so let's maybe go over here. I know the shape, the parabola is up. I have to get through negative 1. So I know I'm not going to do this, because I need to cross the y-axis. Oops. Nice and horizontal start. Oh, come on. Nice turn. Can I not turn very nicely? This is being recorded. Come on, man. Oops. Just make sure you don't have a sharp point there. Right? And it needs to be flat and then turn. And once we get to some calculus, we will see that a little bit more. There is my negative 1 y-intercept. Do I care about x-intercepts? No, I don't. Sometimes, rarely. Because in general, for functions and graphs, that's going to be a recurring theme as we go. Every property has perhaps a certain difficulty, depending on the difficulty of the function. But finding x-intercepts can sometimes be super easy and super complicated, and it's not really in line with everything else. And if there's no need to, I can infer what the x-intercepts are pretty well. And there are methods to do that. It's sort of a side note for us. So unless the question specifically asks, don't waste your time. I'll do it as a side note, but I'm perfectly happy with just these four because I don't need the x-intercepts to tell me the shape of the graph. I have everything already. But just as part of the review, let us just show how we would find the x-intercepts. Just need to make a new page. Again, I'm only doing it if the question specifically asks it, then that's unlikely. So side note, x-intercepts. Well, I know how to find the x-intercepts, and I know from my graph there are two of them. I set y equal to 0, which means my function was 2x squared minus 4x minus 1 equal to 0 is what I'm looking to solve. So then I spend like 10 seconds looking at that. Can I factor that easily? Maybe yes. But if I don't see it quickly, I'm not going to waste my time. Worst case, I have a formula. It is the quadratic formula. Who remembers the quadratic formula? Everyone's hand should be up right now. Really should be. And the reason why we're doing this review is that in case you don't remember something very well, and I mentioned it, that is, I wouldn't say a red flag, but a little warning, go review, 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 review. I'm not wasting your time with stuff you don't need to know. There are many things that we're not mentioning in these first weeks. Feel free to forget that. But if I mention it, it may be useful. So it should be like, what? Grade 10, at least. So many years ago, perhaps. Much opportunity to remember. If I put that in, I have negative 4. B itself is negative 4. Plus or minus root negative 4 squared. I'm just writing all the detail. Minus 4 times A is 2 times C is negative 1. How much you write down to do this is up to you. You just need to be able to do it. Then I'll clean this up a little bit. 2 negatives make it positive, plus or minus. What's the thing inside the square root? I like to do that. Well, this is 16 plus 8, so 24 over 4. So then the plus is going to give me 1, the minus is going to give me another 1, and your calculator does the rest for you. Just to see if you are okay. Using your calculator, someone can give me one or both of the answers. I do not have a calculator. That is where you come in. That is where you come in. Give me one of them, give me both of them. Doesn't matter to me. Should not be too difficult. What do you get for the answer? Let's say 2 decimal places.
2.22.
2.22.
And 0.22. Negative.
Oops, negative 2. Does that fit with what I see in my graph? some reason I can't change the tab. So you have the graph in front of you. And you see that it is centered around 1. So from that axis of symmetry, the distance to the x-intercept should be the same. And it is 1.22. So that does help confirm things. The more information I have, of course, the better. But it's not necessary to calculate the x-intercepts if there's no clear need for that. And rarely there is y-intercept, yes. But it does come up sometimes, so it is important to remember the quadratic formula for when I need it. Any questions so far? Let's do a little application problem, a little word problem. I really have one kind of word problem I'm interested in problem 1.7. Where's my, I can't get to the file, I have to do it this way, which is fine. Problem 1.7, I want to do at least one of them. They're all pretty much the same, so you just need to see one of them. To know how to practice the other one. Problem 1.7, let's just do number 1. So everyone has the problem book in front of them. Get it on your phone, get it on a laptop, get it however you want. But it's on the website. So when I read especially word problems, I expect you to have it in front of you or it's not going to make as much sense. So if you need a minute to go get it, that's totally fine. Now, for many of these questions we do in our review, you don't need the book because I write the function down for you. But application problems are word problems, and it's good to see the word. Yeah, it doesn't happen a lot, but tomorrow it'll happen again. It's good to see the question and make sure, first of all, make sure I wrote the question down right. So it's a good time to, if you haven't, make sure you can get into the website. I spent a lot of time on that website. You can at least log in and see your name and find the problem book. If the questions are really simple, it's not crucial, but in this case we have a word problem. And there are 5 of them. I'll do 1 and you can practice 4. We only have 5 minutes, so you should always have the problem book ready in case we need it. So, number 1 we say, the cost in dollars to produce X, I'd rather be a Sasquatch t-shirt, is given by that cost function. So let's write like that. C for cost. C. And C depends on the number of t-shirts. They define X for me, so I don't have to worry. 2X plus 26. And the price demand function in dollars per shirt is little p. And that's given by 30 minus 2X. Don't worry about the range of X values. We're not going to make things too complicated. I want to know what is the profit function, what is the number of items we need to sell in order to maximize the profit, what is the maximum profit, what is the price I need to charge. That's pretty much it for now. Okay, so this is why I need to do one example. Let's call big P to represent the profit, and let's say big R to represent the revenue, just to help me. Then the big P profit function is how much money is coming in minus how much money is going out. So it's going to be the revenue minus the cost. Money in minus money out. The cost I have a function for. The revenue I don't. The revenue is really how much money I get from selling these t-shirts. If I'm selling X of them at P, little p, dollars per shirt, then the revenue is X times P times little p minus my cost function. And now I have everything. I have the price function is 30 minus 2x. I have my cost function 2x plus 26, and therefore I have my profit function. I can simplify this a little bit to really see what kind of function do I have. But first, did I write that down correctly? Don't just write down what I write down. Think about what I'm writing down. Is that correct? I made a little mistake. What is it? Not in the revenue cost setup. That's all good. In the last line. What is not right? I'm subtracting the cost, not just a part of the cost. All of this needs to be subtracted. That's an easy mistake to make. So I have a negative 2x squared from those two. I have a 30x here and another minus 2x, so that's minus 32x. And then I have a minus 26. So there is my profit function. Now I see that is a quadratic function, which means, and it's in this general form. I'm not going to complete the square on that. That'll be very unnecessary. What I can do is look at little a is negative 2. That means if I were to do the transformations, I would flip it over and stretch it a little bit. So I am going to have a maximum point because of the flip. It's negative. Then I'm looking at my axis of symmetry. That's going to be when x equals negative b over 2a, which in this case is negative 32 over 2 times negative 2. So that's 3 negatives. That can't be right. How do I have 3 negatives? Did I do this right?
It's 32.
It's just 32. I see. This isn't right. Of course, I did that on purpose, and someone noticed. That's not 32, is it? 28. Whoops, Ben, come back, Ben. Totally did that on purpose. You passed. $28. Come on, Ben. Work with me here. Nope, you don't want to work with me? You don't have that much time. Draw a pen. The pen does not want to draw. Press the button. Nope, you're a naughty pen. There you go. So positive 7. So I know it's a maximum. The maximum function value is the profit, because that is the function I'm analyzing. The profit is therefore big P when I plug in 7. And when I plug in 7, you can calculate what I get while I draw a little picture. So someone should tell me what I get for that maximum profit. And we know it's going to go something like this. The highest point here is sitting at 7, but the question also wants to know what is this maximum profit. I can easily get that by just plugging in the x value. Calculator says 72. Can anyone confirm the 72? Yeah, good. So that's the main thing, because we're out of time. I'm just doing very quickly. I can then, from this x equal to 7, go back up here and find, well, what is the price per ticket, per t-shirt, price per t-shirt is little p of 7, and I can calculate that. But the important thing is that my function is a quadratic function, and I can use the axis of symmetry to find that maximum profit value. All the other questions follow the same thing. Just, you can, because we don't have a lot of time, don't worry about the break-even point or anything. That's when the profit equals 0. The important thing is to find this maximum profit.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.